All right, we are going to look at graphing trig functions. So first, let's of course look at our, let's review what our ordered pairs and what our unit circle means. So we know that we have x comma y, and we know that x goes with cosine of theta and y goes with sine of theta. Okay, so to start, let's just graph our sine and cosine graphs. So I'm going to say y equals sine of x. Now, it gets kind of confusing because our x's and our y's, they kind of represent different things right now. But hang in there with me. So if we don't know how to graph something, we always start and we make a table. So let's think about our table here. We have x and we have y. If we make a table, we plug in for x. Now, what will we plug in? We can plug in sine of x is usually sine of theta. So let's plug in degrees or radians here. Well, we're getting more familiar with radians, so let's start there. So if I start with 0, sine of 0, remember sine is our y coordinate on our unit circle, so I'm going to start with 0, 0. So now if I think about plugging in sine of pi over 6. Well, sine of pi over 6 would be 1/2. But then sine of pi over 4 would be square root of 2 over 2. Well, that's a decimal. It's fine. I can work with it. But it's not ideal. So we probably won't use that for every question, but we could start with it now. So sine of pi over 6 was 1/2. Pi over 4, I'm going to get my decimal form of this. So we get square root of 2 divided by 2. So we get 0.707. Then sine of pi over 3 is square root of 3 over 2. So we get 0.866. Pi over 3 is 0.866. And then sine of pi over 2. So pi over 2, we're at the top of our unit circle. Our y value is 1. So we get 1 here. All right, so looking at these points, notice how even though from 0 to pi over 6 we're 30 degrees, we jump up to 1/2. And then from pi over 3 to pi over 2, we're also 30 degrees, but we're a lot closer than we were from 0 to 1/2. So what we're noticing is some kind of trend. So I'm going to just start with a little line here. I noticed that it didn't go higher than 1 yet, so we'll see what happens. All right, so if I have 1 here, then I think it's safe to say that we'll probably continue to go around the circle, right? So if I have 1 there and I go around the circle, then I'm going to end up at probably using 2 pi, right? From 0 to 2 pi. So maybe I'll have my main guys be at pi over 2, pi, 3 pi over 2, and then 2 pi. Because those are equal distances apart, right? They're all 90 degrees apart. So looking specifically at those points, we know that we were at 0, 0. We know from our table that our pi over 2 is at 1/2. Or not at 1/2, it's at 1, right? Pi over 2 is at 1. Here we go. And let's just try a couple others that are specifically on here. And then we have pi. So sine of pi would be at 0. Sine of 3 pi over 2 would be at -1. Let's make a -1. And sine of 2 pi would also be at 0. So it looks like a different shape than we've seen before, but let's see what it looks like in between. So at pi over 6, We're about a third of the way. We're at 1/2 already. And then we're at halfway, we're at 0.707. And pi over 3, we're at 0.8. So notice how it's not linear in its nature. It's more of a curve form to it. So as we continue with this curve, because if we have sine of 2 pi over 3, we'll end up with that same value of 0.8. And then sine of 3 pi over 4 square root of 2 over 2, we'll end up with that same value of 0.707. Sine of 5 pi over 6 is 1/2, so we'll also get 1/2 there. So notice how it's following this curve to it, and we'll see that mirrored in our values down in quadrants 3 and 4. So we have a curved function, and I put arrows there, but let's see what really happens to this. So will it ever go above 1 or below 1? So going back to our circle here, our unit circle, we started at 0, and then we went around, and we saw that our max and our minimums were at pi over 2 and 3 pi over 2. We're looking at our y values. So if we kept adding, if we start at 0, then we went pi over 2, pi, 3 pi over 2, 2 pi, and if we kept going, notice how we'd be at 5 pi over 2, but 5 pi over 2 sine of 5 pi over 2 would still be 1. We'd be at 3 pi, which would still be at 0. We'd be at 7 pi over 2, 7 pi over 2, something like that. But we'd still be at -1, and it keeps going. Our next one, 4 pi, would be at 0 again. So it keeps going, and if I were to kind of zoom out a little bit on this, if I had a graph, I could have keep going. I've got 1, I've got -1, I have pi over 2, pi, 3 pi over 2, 2 pi, and I could just continue with even those values. And what my graph would look like, so we're graphing this green one over again. We start at 0, pi over 2, we're at 1, pi, we're at 0, 3 pi over 2, we're at -1, and then we're at 2 pi. And notice how the pattern continues because we're going in that circle. And it still continues. So your graph, it will have, it won't have linear features. It'll curve throughout. But notice how we just took this, we shrunk it, we put it right here. Notice the features of this graph. So it's, it continues, it's like waves almost. And it just continues. And what else do you notice about it? I notice that I'm going to go up 1 here and I go down 1 there. There has to be some way to describe that. I notice that like I'm going from negative to positive at 0, and then I do the same thing at 2 pi, and then I repeat that over again. So we're going to look in the future at ways to describe that. But for now, I want us to think about what are the graphs of these going to look like. So your job, we just graphed sine of x. Your job for the rest of the day is to graph the rest of the 6 trig functions. So you have time, that's also your homework, is to graph all of the trig functions, and there's extra graph paper if you need some. So graphing y equals cosine of x, y equals tangent of x, And then I would use those graphs to help graph cosecant of x, secant of x, and cotangent of x. So your job is to graph all of those before I see you again, or before your next class. I will see you later, but before the next class that you have. All right, best of luck.